We have De Morgan's laws. First one, we have A union B, the whole complement is equal to A complement intersection B complement. Same way, second one, A intersection B, the whole complement is equal to A complement union B complement. Now this we can solve by taking example that I will show you later how to solve this kind of questions. Now next we have cardinal properties of sets based on union and intersection. Now first one we have, if A and B are two sets, then number of elements in A union B, that means cardinality of A union B is equal to n of A, means number of elements in A, plus n of B minus n of A intersection B. Now for disjoint sets, we know that disjoint sets are two or more sets having no elements in common. So for disjoint sets, A intersection B will be, if A and B are two disjoint sets, then there will be no elements in common and their intersection will be null set. So therefore for disjoint sets, n of A union B will be n of A plus n of B, since n of A intersection B is equal to 0. Second one, we have n of B minus A is equal to n of A union B minus n of A is equal to n of B minus n of A intersection B. Third one, n of A minus B is equal to n of A union B minus n of B is equal to n of A minus n of A intersection B. Now we know that B minus A concept is all the elements in B but not in A. So we can find the cardinality of B minus A by using this formula, n of A union B minus n of A. All the elements, count the elements of A union B, then minus cardinality of A. Same way we can do the cardinality of A minus B. Next, fourth one, we have cardinality of A union B. Number of elements in A union B is equal to n of A minus B plus n of B minus A plus n of A intersection B. Now if universal set U is finite and if A is any set, then number of elements in A plus number of elements in A complement will be number of elements in universal set, if universal set is finite. A complement means complement of A, that means all the elements in universal set but not in A. Now I will show you how to solve this kind of problems. Start with some problems. First we have a question. Given A is equal to set 4, 5, 6, B is equal to set X such that X element of W and X less than 5. W means set of whole numbers. Find A union B, A intersection B, A minus B and B minus A. Before starting the solution of problems, first we have to write the sets. We have to list out the elements of all the sets given in the question. Here A is already given in roster form, but B is given in set builder form. So set builder form means we have to first list out the elements. Now we can start writing the answer given. A is equal to set 4, 5, 6 and B is equal to, it is given here X such that X element of W. So all the elements are whole numbers. And one more condition given, that it is less than 5. So we have to consider the whole numbers which are less than 5. So whole numbers less than 5 are 0, 1, 2, 3 and 4. Now we have to find first A union B. A union B is equal to, we know that when we take A union B, we have to take all the elements of A as well as all the elements of B. So we have to take all the elements starting with the 0, 1, 2, 3, 4, 5 and 6. All the elements from A and B. Next we have A intersection B. Intersection means we have to take only the common. Now in A and B, what is common? We can see that only 4 is common. So we can write A intersection B as set 4. Next we have A minus B. A minus B means all the elements in A but not in B. Which are the elements in A but not in B? See that A minus B means all the elements in A but not in B. So take all the elements of A, 4, 5 and 6, and which of these elements are not in B, 5 and 6. So we can write A minus B as set 5, 6. Then B minus A means all the elements in B but not in A. Elements of B are 0, 1, 2, 3 and 4. Out of this, which are not in A? 0, 1, 2 and 3. So we can write 0, 1, 2, 3. So this is the answer for B minus A. We have another question. Let A is equal to set letters of the word New Jersey. B is equal to set letters of the word New York. We have to find again A union B, A intersection B, A minus B and B minus A. Here also, before starting the answer, we should list out the elements of all the sets. Here we have two sets A and B. We have to list out the elements. I mean, you have to write in roster method or tabular form. So A is equal to, it is given here description, letters of the word New Jersey. We have to write all the letters in the word New Jersey. And one more thing, please be careful, no need to repeat the letters. So we can write the letters by putting commas. N, E, W, J, then next E is already written, so no need to repeat. Then R, S and Y. Then next we can write B. B is equal to set letters of the word New York. New York also we can write like this. N, comma, E, W, Y, O. Then next we have R and K. And one more thing I want to tell, when you write the elements in the set, you should put commas. Okay. Now we have A and B. Now we can find A union B, A intersection B, A minus B and B minus A. A union B means all the elements from set A as well as from the set B. A intersection B means take only the common elements from A and B. A minus B means all the elements in A but not in B. B minus A means all the elements in B but not in A. So do it yourself and complete it. Based on De Morgan's laws, given universal set U is equal to set 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to set 1, 3, 5, 6 and B is equal to set 2, 3, 5, 7. Verify De Morgan's laws. Now in the question it is not given De Morgan's law, so you should know what is De Morgan's law. We have two statements for De Morgan's law. First one is A union B, the whole complement is equal to A complement intersection B complement. Then second one we have A intersection B, the whole complement is equal to A complement union B complement. Now we are going to prove one by one. First one, A union B, the whole complement is equal to A complement intersection B complement. So we should find A union B, the whole complement. For finding A union B, the whole complement, we should first find A union B. A union B we can find from the given set A and B. So A union B is equal to, union means all the elements from A as well as B. So we will get the answer as set 1, 2, 3, 5, 6, 7. Then A union B, the whole complement will be all the elements in the universal set but not in A union B. Here in the universal set we have elements from 1 to numbers from 1 to 9, and we have A union B set 1, 2, 3, 5, 6, 7. So which are not in A union B. A union B, the whole complement means all the elements in universal set U but not in A union B. They are 4, 8 and 9. So set 4, 8, 9. Then for taking the right side we need A complement and B complement, hence find the intersection. So A complement is equal to, A complement meaning is all the elements in universal set but not in A. Here A is given 1, 3, 5 and 6. So except 1, 3, 5 and 6, all the elements from U you can consider for A complement. A complement is equal to set 2, 4, 7, 8 and 9. Same way write B complement. Then take the intersection. Intersection means common. So here in these two sets, A complement and B complement, we can see that 4 is common. Then 8 and 9 is also common. So we can write A complement intersection B complement is equal to set 4, 8, 9. So the first one is verified. A union B the whole complement is equal to A complement intersection B complement. We can see that the left side A union B the whole complement is equal to set 4, 8, 9, and A complement intersection B complement is also 4, 8, 9. So from these two we can say that A union B the whole complement is equal to A complement intersection B complement. Same way we can prove the second one. We have A intersection B the whole complement is equal to A complement union B complement. So for taking the left side, we need A intersection B the whole complement. So first find A intersection B. A intersection B means from A and B take the common. So from A and B what is common? We can see that 3 is common and 5 is common. So we can write A intersection B as set 3, 5. Then A intersection B the whole complement means all the elements in U but not in A intersection B. So except 3 and 5 we can write all the elements from the universal set, that is A intersection B the whole complement. Then already we have written A complement and B complement. So for A complement union B complement we have to take all the elements from A complement and B complement. So it will be 1, then 2, then 4, 6, 7, 8 and 9. 1, 2, 4, 6, 7, 8 and 9. Now we can see that A intersection B the whole complement and A complement union B complement, both these are same. So we can write A intersection B the whole complement is equal to A complement union B complement. Hence the second one is also verified. So this is the way we have to verify De Morgan's law. Question: if n of A is equal to 20, n of B is equal to 16 and n of A union B is equal to 30, find n of A intersection B. We have to solve this problem according to the cardinal property of sets. N of A means cardinality of set A, number of elements in set A, that is given as 20. Now cardinal property of set, first one we have seen that n of A union B is equal to n of A plus n of B minus n of A intersection B. Okay, now here we have to substitute the values of the given things. Here first one, n of A union B. N of A union B is given as 30 is equal to n of A is given as 20 plus n of B is given as 16 minus n of A intersection B. Now we can solve 30 is equal to 20 plus 16, it is 36 minus n of A intersection B. Now minus n of A intersection B we can take to the left side, then it will become positive, and this 30 we can take to the right side. So it will become n of A intersection B. Here minus n of A intersection B is on the right side. When it is taken to the left side, it will become positive. Is equal to, already after the equality sign we have 36. Then 30 when it is taken to the other side, it will become minus 30. So 36 minus 30 is equal to 6. So we can say that cardinality of A intersection B is equal to 6. Next question: there are 10 elements in a set A, 7 elements in set B and 14 elements in set A union B. Are the sets A and B disjoint or overlapping? Also find A intersection B. Now First we have to write the given things. There are 10 elements in set A. 10 elements in set A means cardinality of set A is equal to 10. Then 7 elements in set B, that means cardinality of set B is equal to 7. Then 14 elements in set A union B. So cardinality of A union B is equal to 14. Now we have to find whether the two sets A and B disjoint or overlapping. Now in cardinal property of sets we have seen that for disjoint sets A, n of A union B is equal to n of A plus n of B. If the cardinality of two sets are equal to the cardinality of their union, then we can say that they are disjoint, since cardinality of A intersection B is equal to 0. For disjoint sets there is no element in common, hence the cardinality of intersection will be 0. Now here n of A is equal to 10 and n of B is equal to 7. So 10 plus 7 it will be 17, which is not equal to the cardinality of A union B. Cardinality of A union B is equal to 14 and cardinality of A plus cardinality of B is 10 plus 7, that is 17, and which is not equal. Hence we can say that the two sets are overlapping. So two sets are overlapping. Now we have to find the cardinality of A intersection B. So like last example, we can find n of A union B is equal to n of A plus n of B minus n of A intersection B. Now cardinality of A union B is how much? 14 is equal to n of A is equal to 10 plus n of B is equal to 7 minus n of A intersection B. 10 plus 7 is equal to 17 minus n of A intersection B. Now if you take, like last example, if you take a minus n of A intersection B to the left side, it will become positive. So n of A intersection B is equal to, after equality sign we have 17, then 14 when it is taken to other side will become minus 14, and the answer is equal to 3. So therefore we can see that the cardinality of A intersection B is equal to 3. Another type of question based on cardinal property of sets. If n of universal set U is equal to 35, n of A minus B is equal to 15, n of B minus A is equal to 10, and n of A intersection B is equal to 5, show that n of A union B is equal to 30, n of A complement is equal to 15, and n of B is equal to 15. Now here we should know the cardinal property of sets, and the first thing, always remember when you are asked to solve this kind of questions, always find n of A, n of B and n of A union B. N of A, n of B and n of A union B. Now for finding these three things we should know the cardinal properties. First one, for finding n of A, we have n of A minus B is equal to n of A minus n of A intersection B. Now here in this statement, n of A minus B is given as 15 and n of A intersection B is given as 5. So substitute their values. N of A minus B is equal to 15 is equal to n of A minus n of A intersection B is equal to 5. Now therefore n of A is equal to, if you take this minus 5 to the other side, it will become 15 plus 5, which is equal to 20. Next we are going to find n of B. Same way, for finding n of B we can write n of B minus A is equal to n of B minus n of A intersection B. Now substitute the values of n of B minus A. N of B minus A is given as 10. So we can write n of B minus A as 10, which is equal to n of B minus n of A intersection B. N of A intersection B is given as 5. So we can substitute here 5. Therefore, n of b is equal to, when you take minus 5 to the other side, it will become 10 plus 5, which is equal to 15. So we got the value of n of a and n of b. Now we are going to find the value of n of a union b. Now we know that n of b minus a is equal to n of a union b minus n of a. Otherwise you can write n of a minus b is equal to n of a n of a union b minus n of b. So here I am taking n of b minus a is equal to n of a union b minus n of a. Now n of b minus a is already there, 10. So substitute 10 is equal to n of a union b, which is unknown, minus n of a, we have got 20. So minus 20. Now this minus 20 we can take to the other side. So it will become n of a union b is equal to 10 plus 20, which is equal to 30. Now we have to show that n of a union b is equal to 30. That is shown here. N of a union b is equal to 30. Next, the second one, we have n of b is equal to 15. We have here n of b is equal to 15. N of a complement. For finding n of a complement, we can use this formula. We have a condition: if universal set is finite, then n of a plus n of a complement is equal to n of u. And here in this question given that n of u is equal to 35. That means universal set is finite. So we can use the formula n of a plus n of a complement is equal to n of u. Now therefore n of a complement is equal to n of u minus n of a. Then substitute the value. N of u is 35. N of a is how much? N of a is equal to 20. So 35 minus 20 is equal to 15. So we have shown that n of a complement is equal to 15.